Hi guys, welcome to another physics video. In this case, we're going to see the analysis of the graph of position versus time. I repeat, this is X means for position versus time. So in all the graphs that we're going to see, the time will be always the independent variable that I got right here. The independent variable is the x-axis or the horizontal axis, and the dependent variable will be this vertical axis or the y-axis. So this is position that is going to be measured in meters, if you can see it. And right here, I got the time that is going to be measured in seconds. So this is the graph that I have, and we are going to make the analysis, the proper analysis of this problem. Let's say this is a problem, and this is just a simulation about it could be a person or it could be a car, any object that you want to imagine. This object is moving. So imagine, for example, let's say that this is a person, okay? And I got, for example, I got the house over here. Let's say this is the house. Okay, so right here in the house is 0 meters, the position. So I got the line. It's supposed to be a straight line. So this is 0. I got 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, and so on and so on and so on. So for example, in this problem, if you see, the line begins at 3 meters. Do you see that? 3 meters. So the person starts the motion here. That's the person. And that person is going to remain in 3 meters for how long? For 1, 2 seconds. Do you see that? It's going to remain there for 2 seconds, and then is going to the position 1 meter. So that means that it's going to travel back. It's going to jump back, and it's going to stay there at 1 meter for how long? For 1 and 2 seconds. So that is, for example, how we're going to see this graph shows the behavior of this person. So before we continue, I'm going to separate the segments of this graph. If you see, for example, there are different types of inclinations. Here at the right, I'm going to draw, for example, we got the horizontal line, and also we got the line with inclination that goes upwards and the line that goes downwards. Those are the different type of inclinations that I have. So I'm just going to separate those segments. So for example, I have horizontal line, and then it's going to change. So here I'm going to separate this from this segment over here, and then goes downwards, and then horizontal, and then goes upwards. There's another segment, goes upwards and then goes downwards. Okay, this is another segment of change in the inclination, and then goes upwards and then horizontal. So this is another change. Okay, I'm just separating the segments of the graph. Horizontal and then goes downwards. Okay, so those are the segments, and with another color, I'm gonna call that this is the segment number 1, 2, 3, 4, 5, 6, and 7 segments. Okay, 7 segments or 7 different segments through the whole motion of this person. So as I said before, in the segment number 1, okay, this person is going to stay there, and then he jumps to the position number to 1 meter, and he's going to stay there for 1, 2, 3, 4, 2 seconds, and then after that he's here. So he's going to go to 4 meters. So after being here, he's going to move to 4 meters. Okay, now I'm in 4 meters. If you see, this is 4 meters. And then after that, immediately I'm going to jump to 5 meters. And of course, these motions, they require time. For example, here in the segment number 4, well, it took him only 1 second. In the number 5, it took him 2 seconds. So in the segment number 6, if you see, this person is going to stay there at position number at the position of 5 meters. He's going to stay there for 5 seconds, and then is going to return to 0 meters. If you see, goes down, goes down, goes down, and is going to take 2 meters in order to return to 0 meters. So we can say that is the analysis of the motion. I mean, if we want to describe how were his motions or his movements, well, that would be an explanation. Okay, so now what about these lines? If we remember, this is position versus time. So the horizontal line, what does this mean? What does it mean if I have a horizontal line? Well, that means that this person is not moving, so there is no motion. No motion. And if there is no motion, that means that the velocity equals 0 meters per second or kilometers per hour, as you wish. Velocity equals 0. Now, if I have an inclination that goes upwards, remember the definition. Velocity is a change in position. So that means that I move. If I have an inclination, that means that I move. I move here, I move here, I move here, and I move here. In the horizontal lines, that person did not move. So if I have an inclination that goes upwards, well, I'm going to have a velocity, and that velocity is going to be positive. And if I have an inclination that goes downwards, I'm going to have velocity, and that velocity is going to be negative. Remember, velocity is the change in position. How do we know that there is a change? Because we have an inclination, and that inclination could be upwards or downwards. Okay, now the thing that I'm going to do is that I'm going to find the velocity in each one of the segments. But for example, the velocity of the segment number 1, well, I just told you, if there is a horizontal line, that means that the velocity is 0. So the velocity, I'm gonna write it here, the velocity of the segment number 1 equals 0 meters per second. Yes, but what about the other segments? Okay, so there is a formula that I'm going to write over here that says velocity equals the final position minus the initial position over the final time minus the initial time. And that is the formula that I'm going to use in order to find the velocity of each one of the segments. So for example, let's find the velocity of the segment number 2. Okay, I'm gonna write here velocity, let's hit it with the black color. Velocity of the segment number 2. So each one of the segments has 2 points, final and initial. This is the final point of the segment number 2, and this is the initial. Now I recommend you that the final point is the point that is at the right, and the initial point is the point that is at the left, but that is my recommendation. So in the segment 2, this is the final and this is the initial. So I'm going to substitute final position of the segment 2. Final position, if you see, this is the final and the position is this axis over here. So final position is 1 meter. 1 meter minus the initial position is 3 meters over The final time here is 3 seconds minus the initial time, that is 2 seconds. So it will be 1 minus 3 is minus 2 meters over 1 second. So that is the velocity of the segment number 2, and I'm going to write it here. Velocity of the segment number 2 equals minus 2 meters per second. And it's negative. Why is negative? Because it's going to the left. Remember I told you about the reference system. If I have a reference system, if I go to the right, it's going to be positive. If I go to the left, it's going to be negative. So in the segment number 2, I'm in position number 3. And then I'm moving to position number 1 meter. So I move to the left. That's why the velocity is negative. Velocity is a vector. The number is the magnitude and the sign is the direction. So what about the velocity of the segment number 3? Well, that's an horizontal line. So velocity equals 0 meters per second. Okay, let's find the number 4. Okay, number 4 equals the final position. Okay, final position of the segment number 4. Segment number 4 is this point, final, and this one is initial. So the position is 4 meters minus 1 meter over, and the final time 6 seconds minus 5 seconds. So this will be 4 minus 1 is 3 meters over 6 minus 5 is 1 second. So this will be the velocity of the segment number 4 equals 3 meters per second, and it's positive because I'm moving to the right. I'm in position 1 meter and then I jump to 4 meters. Okay, let's find the velocity of the segment number 5. I'm gonna do it here above. Velocity number 5. That segment has 2 points. This is the final and this is the initial. So velocity of the segment number 5 equals final position is 5 meters minus initial position minus 4 meters over final time 8 seconds minus initial time 6 seconds. Okay, this is 5 minus 4 equals 1 meter over 2 seconds. So that is the velocity of the 5th second. That is going to be 0.5. I'm going to write it here. So velocity of the 5th segment is 0.5 meters per second. If you want to say, for example, in 1 second, in the segment number 4, in 1 second, this person traveled 3 meters. That's what it means. In the segment number 5, in 1 second, this person traveled 0.5 seconds. Okay. Segment number 6. If you see segment number 6, oops, I'm gonna write them over here. Segment number 6, well, the line is horizontal, so that means there is no motion. That means that I got 0 meters per second. And the segment 7. The segment 7, this is the final, and this is the initial. Okay, so velocity of the segment number 7 equals final position. The final position, if you see, I return to 0 meters minus the initial position is 5 meters over the final time 12 seconds minus the initial time 10 seconds. So this is minus 5 meters, negative because I'm returning, I'm moving to the left, over 12 minus 10 is 2 seconds. So 5 over 2 is 2.5. So the velocity of the segment number 7 is minus 2.5 meters per second. Okay, so that means that in 1 second that person travel um, 2.5, yes, 2.5 meters. And this is the first graph, position versus time, yes. And the most important thing about this is that you identify that horizontal line means that there is no motion, means that there is no velocity. Velocity in this case is negative, in this case the velocity is positive. Got it? So stay tuned guys, because we're gonna have more videos about physics. Bye bye.